All right, so here's a short primer about the different factors involved with making STEM content accessible. I'm Krista Greer. I work with Blackboard Ally, and I also currently serve as Vice President of Athen, an organization focused on accessibility and technology in higher education. These comments are accurate as of August 2021. So here's a graphic that's describing the different factors. There's several of them, so I'll verbally mention each of them and then go through and add some more context to each. Location of content, how math was created, file types, the operating system, end user's tool, web browser, the person's needs, the owner, the time frame, the motivation for making that content accessible, whether it's a legal compliance issue or a universal design for learning desire, and is the student majoring in STEM? So the first factor involved is the location. So where is the STEM content created? Is this in physical handouts, electronic documents, websites, videos, online learning tools, whiteboards, library journals, or is it in the learning management system, also referenced as virtual learning environment in some contexts? The second factor is how the math was created. So is this an image of the mathematical expression? Is this text being like using your keyboard to say 1 + 2 = 3? Is it in LaTeX or LaTeX, depending upon how you say it? Or is this in MathML? So it's important to understand the differences between LaTeX and MathML, since the accessibility industry is often going to recommend that you utilize MathML for many circumstances, but LaTeX is what most faculty members and instructors are familiar with. So the differences between the two. LaTeX is a document preparation system designed for the scientific and technical communities. It was designed for the printed world, and it is the de facto standard for communicating this type of content. It is written by humans, so it's just a specific syntax and symbols and characters and meanings to create pretty complex math. It was initially released around 1984, so about 37 years ago. MathML is actually a computer markup language. It stands for Math Markup Language. It's a low-level specification for mathematical and scientific content in our digital world because it was designed for the digital world. And it's been in HTML5 and ISO standards since 2015. However, this is not meant to be constructed by hand due to length. So you often use an equation editor or some other type of interface to create MathML. And it was released in around 1998, so about 23 years ago. So immediately we can see some very distinct differences between these two. Here's a visual example of the differences between the quadratic formula in LaTeX versus MathML. In LaTeX, it's pretty short. There's several characters involved, but it's very reasonable. It's just one line of text. MathML, however, is several lines of information because it's using that markup language to really communicate the different aspects and characters and components of the quadratic formula. Typing something by hand using LaTeX, totally reasonable. MathML, to create that several rows of information by hand is not reasonable, which is why to generate MathML, you are often going to start with LaTeX and use some type of converter into MathML, or you'll use an equation editor to create it visually, and then on the back end, the markup language is being generated. Next up, file type. So is the content a Word file, PowerPoint, HTML? Is it within a learning management system or VLE? Is it in Google Docs? Is it in a text file? All of this comes very much into play about what the next steps are. The operating system, both from a creation perspective, but also the end user's perspective. The way that I might create accessible STEM content in the Apple environment is different than the way I might do it in Microsoft and Windows, simply because the tools available to me are different. And sometimes tools, if they are available in both operating systems, they're not an equal experience. What about Google's Android OS? What about Linux? What about Apple iOS? What is the student actually using to interact with this content? The end user's tool. So there are three main categories of assistive technologies that I think of when I think of accessible STEM content. We have screen readers, we have text-to-speech engines, and we have speech recognition. Screen reader, JAWS, NVDA VoiceOver, text-to-speech, something like Read and Write, Kurzweil, Mac text-to-speech, VoiceStream, and speech recognition, Dragon Naturally Speaking, or others. What the end user's tool is very much would impact the process and techniques and tools I would use to create the math. Ideally, we would have a process and tools that would produce accessible math that would work for all of these assistive technologies. But also another consideration is how long has the student been using their technology? It is entirely possible that someone could create beautiful, accessible STEM content that will work with a screen reader, but if there is a student who is new to a screen reader and doesn't know quite what buttons to press and keyboard shortcuts to use and so on, it's possible that they may not have a good experience. So web browsers, Chrome, Firefox, Safari, Internet Explorer, Microsoft Edge, all of these things very much come into play as far as what the content is going to look like, how it will interact with assistive technologies, and just general support. For example, Chrome and somewhere around version like 46 supported MathML natively, but then that support was removed in subsequent versions. So now you actually need to rely on something called MathJax often. It's a JavaScript library to help really render and communicate the MathML to assistive technologies in most browsers. The person's needs. So what does the end user actually need? Do they just need to enlarge it, right? If that's the case, then having a scanned version may work just fine. But if they need to use assistive technology to hear that math content be read aloud, then we're in a totally different ballpark. Also, does the student need to input math? Do they need to create math? Are they trying to solve problems? Are they trying to do homework? Are they trying to answer an exam? Ownership. So did the faculty member or instructor create this? Did they get it from a colleague? Is this from a publisher? Did you purchase this content? Is this open educational resource content? All of these very much affect how much control you feel you may have in making the content more accessible in the first place. Time frame. Do you have several weeks or months to work with experts at your university or college to figure out how to systemically make STEM content accessible? Or did you just get a very recent request where you only have a matter of days to figure out a solution? In some situations, it may be easiest to pay a professional accessibility remediation company to fix that content and make it more usable. In other scenarios, it may be more cost-effective if you have the time and expertise to build up your own internal solutions at your institution. Next, what's the motivation? So many of us understand accessibility to be a compliance or a legal issue, especially in countries where there are strong disability laws, which basically says if there is an accommodation request, if there is a student with a disability, then you have to find a way to make that content usable for that student in an equitable way. However, more faculty members and instructors are actually trying to think proactively. What can I do now to remove barriers for my students even though I don't have an accommodation request? So the motivation for making this content accessible very much comes into play. The last consideration is the student majoring in STEM? So is accessible STEM content needed just for one course, or is it needed throughout the duration of an entire program? Also, does the student know LaTeX? If the student already knows LaTeX, then giving them the tech files may be really sufficient and really perfect for that scenario. If the student doesn't know LaTeX though, if they are majoring in STEM, it might be reasonable to expect the student to learn LaTeX. If the student is only taking 1 or 2 courses though, I don't think that's a reasonable thing to ask of student for them to learn LaTeX that will be utilized in only 1 or 2 courses in their program. In conclusion, I hope that this has given you greater insight as to why STEM accessibility is complex because of the different factors involved. It totally depends upon the details of the specific scenario in which you are facing. Some of these factors may apply, some of them may not. I hope that you will keep learning and that we can keep the conversation going so we can one day have more tools and more techniques to make more of our STEM content accessible from the beginning.